Hello, everyone. Welcome to PyData Global 2021. I am Conrad Ho, one of the chairs of this conference. We're very happy to welcome Kalyan today. He is a self-taught data scientist who is also a core member and meetup organizer and committee member of PyCon Hybridat and India, here to talk to us about NeuroProfit. Thank you. Please take it away.
Thank you for the warm introduction, Conrad. Hey, folks, I'm Kalyan Prasad. Today, I'm going to talk about NeuroProfit, a powerful AI framework for time series model. Before I actually jump into my actual presentation, I would like to sincerely thank and give credits to the Oscar Tripp, who is the author of a NeuroProfit, for creating an amazing tool for time series models. So here's a quick intro about me. I'm a self-taught data scientist and analytics manager, currently working with one of the startups based in Hyderabad. And I also love involving with different communities, and I love helping communities in multiple ways. Currently, I'm associated with the following organizations. So where I have different roles and different responsibilities altogether. And I also love to give back to communities always. So I always look for opportunities to share my knowledge. That's pretty much about me. So here is the agenda for today's talk. We'll start with a quick intro to time series. Then we'll see what is NeuroProfit and why we actually need NeuroProfit, and what is the difference between the original profit and the NeuroProfit. Then we'll straight away jump into action to see the power of NeuroProfit, and I'll wrap up my talk accordingly. So feel free to post your questions at any point of time. I'll definitely answer each and every question as much as I can. Without any further delays, let's get started. Time series. So there are so many definitions of the time series which are available on the internet, out of which indicate same meaning in a different way. A pretty straightforward definition is sequential data order matters. A time series is a sequence of observation taken sequentially in time. When you are forecasting time series data, the main aim is to estimate how sequence of observations will continue in future. So observations are typically collected at regular intervals, like every day, every week, yearly, monthly, etc. For example, if you are talking about weather data, we may receive weather updates for every 10 minutes or every hour. Or if you are talking something about IoT sensor like that generate the data continuously. So depending upon the source of the generation, we may have different frequencies at which data is collected. Advancements in machine learning have increased the value of time series because there are so many prediction problems that involve time component. That is why it is like booming in the industry now. Organizations also apply machine learning to time series data to do forecasting. They also compare the seasonal and cyclic patterns because time series forecasting helps us to predict the future values of a critical field, which has a potential business value in the industry. For example, predicting the health condition of a person, or predicting the performance of a player, or predicting the performance of sport based on the previous performance or a previous player data. I believe that time series has literally spread his wings across everywhere. So that is why it is everywhere. Now here comes our main topic, NeuroProfit. So here is a quick visual representation about NeuroProfit. So it is a Python library for time series modeling data. And NeuroProfit is a neural network-based model that uses the PyTorch framework as a backend. And it has a modular architecture that allows so many futures to be plotted in the future. And this library is heavily inspired from Facebook Profit and ARNet library. The authors of this library are the research from the Stanford University in collaboration with Monash University. And what more you need to know about NeuroProfit? This library is a beginner friendly, and one can easily set up and start building a time series model. It also addresses pain points such as scale, customization, and extensibility. With this library, you can easily scale. Your model can be completely scalable, and you can also customize or adjust your model according to your needs. Of course, without changing the core code base, you can also edit or manipulate the code. This is amazing. Just like profit, NeuroProfit is also decomposable with all time series components like trend, seasonality, auto regressor, future regressor, likelihood regressors, recurring events, etc. This library is absolutely an upgraded version of a Prophet because it uses deep learning models such as AR network for time series forecasting. Now, why we actually need neural Prophet? I mean, like, what is the power of neural Prophet? It aims to solve the seesaw of uncertainty. What do I mean by this point? I guess you are already aware of autoregressive models. Autoregressive models are nothing new, but they usually use linear fit with a least square instead of a neural network with backpropagation. Autoregressive neural network mimics the traditional AR process with a neural network. So it is a single layer network that is trained to mimic the AR process in a time series signal at a very large scale comparatively with traditional models. ARNet also scales much better to the larger data set and more inputs. For example, if you look at this below graph, you can see that the training time of ARNet doesn't increase exponentially with the AR order. And another important thing which I would also like to mention here is about the p-values. So p-values here are the number of autoregressives used in the autoregressive models, not those PRS which we use in the hypothesis testing. This is something you should remember here. Neural Prophet also upgrades Prophet linear external regress to feed-forward networks because deeper equals to better. So the deeper the feed-forward networks, the better our model runs fast and the better we have results and accuracy. That's the power of a neural Prophet. Again, adding neural networks to the Prophet has a downside because the amount of a learning parameter increased dramatically. To sync with that, neural Prophet uses PyTorch framework as a backend instead of a stand, and it trains with a stochastic gradient descent, which is an amazing thing about the neural Prophet. Now, here comes the difference between the original Prophet and the neural Prophet. Okay. When you are exploring time series data or you are learning time series data at any point of time, definitely you will encounter a popular package called Facebook Prophet. The reason is that it has gained a lot of popularity due to the fact that it provides a very good performance in terms of accuracy and interpretable results. The best part of Facebook Prophet is it also automates a lot of elements such as hyperparameter tuning or feature engineering for the users. That is why Facebook Prophet is a pretty straightforward to use for data scientists or any other folks who are playing with the time series data, or even for the folks who has a very less technical knowledge. When coming to neural Prophet, the author also had same thing in mind by retaining all the advantages of the Prophet by focusing, improving the accuracy and scalability. So using ARNet to scale the neural networks with the interpreting of autoregressive models. So these are some of the core differences or the features which are existed in neural Prophet comparatively with the Facebook Prophet. It's like gradient descent for optimization. Since neural Prophet uses a PyTorch framework as a backend and it trains with a stochastic gradient descent, which makes our modeling much faster. Time series autocorrelation is modeled using the autoregressive neural network. So this is again amazing thing here. Our laggard resources are trained using a separate feed-forward networks. Additionally, our model is also configurable to non-linear deep layers of the feed-forward network. So this is again the amazing feature which is existing in the neural Prophet. The best part is it also offers a lot of custom metrics and losses. Apart from this great features, another great feature of a neural Prophet is it gives developer access to the ARNet library, which was developed by Facebook researchers. So that's the amazing thing about neural Prophet. So I think I have given so much enough to download on theory. So let's jump into action to see how neural Prophet works in a real time. So let me switch back to my core notebook now. so So here's a notebook for today's presentation. So the goal of this notebook is to show you how neural Prophet is used for forecasting time series model. And we'll see that in a while. So And before I walk through the presentation code, let me tell you something here. So I've already executed the entire code for this demonstration in order to save time, because it takes a couple of times to execute the code. So instead of wasting time, I have already executed. I explain each and every part of the code. However, I would also run few snippets to show you some cool stuff in this demonstration. Okay, when it comes to installation of neural profit, there are multiple ways you can do it. So you can simply pick install, or you can, if you want to run neural profit in a Jupyter notebook, you need to install neural profit live, because this will enable live plots for both training and validation costs. Or else, if you want to have an up-to-date version of a neural profit, simply go to the GitHub repository and clone the repository and start playing with it. So it's up to you how you want to do it. So in my case, I have installed the live one in Jupyter Notebook here, so which is already done. So basically, this notebook has been classified into two sections. In the first section, we'll simply see how to create a simple baseline model using neural profit. In the next section, we'll dig into bit detail about neural profit to see some additional information or additional stuff involved in the neural profit. Okay, so as usual, we'll import necessary suspects here. So I have done the same thing, and from neural profit, I have imported a random seed as well. So I'm setting my random seed with a random number to make sure that results are reproducible when every time our model runs here. So I've taken the retail sales CSV data from our neural profit GitHub page. So I've just executed that, read the data. So here are the first 10 rows, and here are the last 10 rows of our data. So just like profit, neural profit also requires to do some reformatting on our data frame before we pass it to our model. So all we need to make sure that our data is a correct data type, and it should be renamed as a DS, and our prediction parameter should be named as a Y. So in our case, we have already done that, so we don't need to do any reformatting here. So we are good to proceed further. So we can simply create a model and validate a neural profit with very few lines of code. So it is you see now. So I have initiated my neural profit model here, and there are so many options and parameters which it can also pass in this model to improve the accuracy or improve the results of the neural profit. But however, for this time, for the moment, we'll keep things simple, and we'll simply run a baseline model. So I'm not passing any parameters here. So okay, then I'm fitting my model, passing my data, and also a couple of parameters here. So validate each epoch, which is nothing but whether to validate the model performance on validation data for each epoch. So valid P, it's nothing but it is a floating point between the 0 and 1. So indicating that the distribution should be used for training. The proportion of the data should be used for training. Plot life loss, so which will enable to show you the live plot for training and validation plot, which you'll see now. Epoch is nothing but the number of epoch that should be used for training here. So once I execute this, just observe this live plot. It should take a few seconds to run. Okay. Notice how our plot and last values are changing after each epoch. So if you remember, just focus again that observe that how our plot and loss values are updating after each epoch. This is what you see in this plot. Okay, yeah, just observe that yeah, this is something amazing here. And also generating prediction is also pretty straightforward. So in order to generate predictions in neural profit, you need to create a feature data frame. So as the name suggests, we need to create a new data frame of the date that extends our original data frame. So this is exactly what I'm doing here. So I'm creating my future data frame, passing my data, and also giving a period as 365, meaning that I'm creating a 1 year future data frame on my existing data frame. Then I'm passing my future data frame to predict function to return our forecast. So once I execute this, there we got a future data frame. So just in case if you are not sure, just in case if you get confused that whether it is a future data frame or not, just go and check our original data. So our original data has started at 1992-011 January, and our data frame ended at May 1st, 2016. And if you see our future data frame, it started at May 2nd, 2016, and it has ended at 2017, May 1st. So it's again 1 year data. And another thing is it also identifies the y-hat predictions, trend value, and yearly seasonal value, which is again the amazing thing here. And it is also common that the y and residual values to be none here. So this is an expected behavior. So you don't need to get panic when you see such things. Okay, so we got a future data frame. So let's plot our model now. So let's plot our model and see how the results are. So plotting our model is pretty straightforward. We just need to use the model.plot function and pass our future data frame, and there you go. And notice how our model is able to learn the seasonal parameters on our retail sales data. And you can also plot the model components as well. This is again a pretty straightforward. We need to call the model.plot components and pass the future data frame. There we get our model. What I mean, the plot component values as well, the plot component graphs as well. See, so notice it shows a solid decreasing trend for our retail sales data. And if you also look at the seasonal yearly values, and particularly if you observe December being the busiest month comparatively with the other months in the retail sales data. So this is how you gain insights. And these plot components are really important for domain experts because they visualize this insight. They will look into this insight to understand the overall forecasting process, and they adjust their model accordingly. So these plot components play a really key role for the domain experts. So that's pretty much about for creating a simple baseline model on the neural profits. So now we'll jump into the next section. In this section, we see why neural profit is powerful. So neural profit is especially powerful for time series forecasting data because takes additional information into consideration, such as trend, seasonality, autoregressors, recurring events. So we'll see all of this additional information one by one with a real-time example. So for this section, I have taken altogether a different data set from Kaggle called Nifty 50 data set. So in that, I have picked Marti company. So I have read the data. So there we got our first 5 rows of data. And if you also look at the info, so these are all the information about the data frame. And we have total 4,427 rows and 15 columns on our data. So as I mentioned earlier, we need to do some reformatting on our data frame before we pass it to our model. So this is exactly what I've done here. So I've selected my data frame and selected 2 columns called date and VWAP. VWAP is nothing but the volume weighted average price, which is a trading benchmark for a trader that gives an average price of a security that has been traded throughout the day based on the price and volume. So this price is really plays a key role for the traders. So I've selected that column from Marty stock. Then, since if you notice that our date is an object column here, so I want my date to be in a datetime object. So that is what exactly I'm doing, applying my date to a period datetime function. This will convert my date from object to a datetime. Once I execute this, so we got a date and volume weighted average price columns. Okay, now let's start looking at our additional information. So we'll begin with trends. Now, what are trends? A trend exists when there is a long-term increase or a decrease in the data. So it does not have to be linear always. It might change its direction from an increasing trend to a decreasing trend. So what I'm doing is I've selected my data frame here and selected a volume weighted average price, and I'm simply plotting it. So if you observe this visualization, we can see that it shows a general increasing trend for our Marti stock price, where certain points a price rise and falls. So we consider these as we consider those as our changing points. With this now, what we do is we train our neural profit model on our Marti stock price by focusing only on the trend as our first version of a model. So meaning that we'll be building our neural profit model only focusing on the trend as our first version. So let's see that. Okay, before we start building our model, so we need to rename our columns. So our date column should be in DS and our predictor parameter should be Y. So this is what I have done here, resetting my column and renaming my columns. There we got our columns now. We are good to proceed with the modeling. So now I've initiated my neural profit model and I've passed a couple of parameters here. So we'll see what are those end change points, which is nothing but specifying the number of points in a broader trend. So rate of increase or decrease when the data changes. So trend reg is nothing but it's a regularization parameter that controls the flexibility of a changing point. And yearly seasonality, weekly seasonality, daily seasonality, it falls because we are only focusing on the trend. So that's the reason. So those parameters has been kept as a false. Okay, now we have initiated our model. Next, I'm fitting my model and passed all the parameters. So you have seen all these parameters in the first section. So there is no change in that. So I'm so I'll not explain the same thing again here. So let me run my live plot again here. So just notice that now how my live plot changes here. See how the live plot is changing here and how you gain insight from this live plot. So this is a very interesting, with the live plots. So based on this live plot, it looks promising. However, even after a lot of volatility, the model has converged. Okay, so if you didn't get this point, so let me explain in a better way. So what we'll do is, so instead of understanding by this, so let's plot our model forecast plot to understand how our model performs. So what I've done is I have created a custom function called plot underscore forecast, where I have passed a couple of parameters. C called model is nothing but our neural profit model here. Data is nothing but the data which we use for training. Periods is nothing but specifying the number of periods we want to forecast. Historic spread is nothing but whether we want to plot our model forecast on historical predictions. Highlight step ahead, the step ahead to show the forecast line. So this parameter is only used for auto-regressive models only. So this is what I have created now. Now what I'm doing is I'm creating my future data frame here. So I've created my model.make future data frame where I'm passing my data, I'm giving my periods and also giving my historical prediction data. So once I've created my future data frame, I'm passing my future data frame to predict function to return the forecast on the data. And also return a quick conditional statement here, which is like, if highlight step ahead is not none, so I want my model to highlight the step of each of the forecast line in the plot. Otherwise, simply just plot the model forecast. So this is what exactly this snippet of code here. So then I called my plot underscore forecast function where I passed my model, where I passed my data frame and given the period as 60, which is nothing but so I want my model to predict a 2 months data. So once I execute this again, so you will see we can now see our commodity stock prices on the historical prediction as well as our forecast data. So by looking at this visual, so it is very clear that our model is able to capture the general increasing trend for our commodity stock data. But however, it seems to suffer from with underfitting, particularly in the years of 2008, 19, and 20 that was likely used for validation. So let's also look at the forecast plot. So this is again forecast plot is also pretty simple.
Hi, Kalyan. Just a quick 5-minute warning.
Yeah. Okay. So let's also look at the forecast plot. It also shows that it shows here historical prediction false. It shows a solid increasing trend here. So let me tell you something. If stock price was that easy to predict, no one in the organization will generally hire a financial advisor or portfolio advisor to manage their stock. So this makes sense, right? So what we can do is we can scale our model by considering seasonal parameters, seasonality parameters into the consideration. So initialize its seasonality. So now we are training our model on seasonality, same parameters here. Now look at this. So if you look at this plot now, so, so our seasonality plot looks a bit realistic compared to what we have seen here, but however, it still suffers with some underfitting here. And again, if you look at our forecast of seasonality plot, it shows a smooth curve. So but you hardly see the stock market move very smooth. Most of the times, if you observe, the stock market looks so uneven and very confusing, and sometimes you also get scared by looking at the stock market. So this is again, so there is again a problem with here as well. Now with ARNet library, so with ARNet library, again, I'm passing the same parameters. Now I'm training our model. So if you observe our ARNet library graph, ARNet visualization, the model looks a bit realistic, and it also able to capture the movements of the stock market. This is again amazing. So comparatively with trend and seasonality, autoregressive model has done a great job. So autoregressive models are a class of models that are able to capture that are able to predict the future values of a variable based on its past observation. So we are predicting here by considering past historical data for 2 months to predict the future historical data. So this has done an amazing job here. Even I also consider the recurring events into the consideration. We can also see the plot. So this is how the recurring event plot looks like. But however, if I compare that, no, there is no much change even after taking recurring events into the consideration. So finally, what I would like to conclude here is predicting a stock price is not that easy in real time. But however, our model has done a good job. Our AI model has done a good job in terms of capturing the general increasing trend in the stock market. To be on a suggestion side, I generally not recommend to use this model for your own trading, but I believe that this is a good demonstration capabilities of explaining the neural profit in real time. And finally, what I would like to say is there is so much more you can do with neural profit. For example, you can also explore with the autoregressive, how large regressive works with neural profit. So you can experiment that. But I believe that this is plenty that at least you can get started with neural profit. With this, let me switch to my slides once. And so as I mentioned that neural profit is quite new library. There can be a lot of things happen in the future. And also, so one thing you should remember here is that not all the features from the original profit are already implemented in the neural profit. So they may get implemented slowly. And as per the GitHub documentation page, so these are some of the current features which will be featured in the upcoming versions of the neural profit, like logistic growth for trend component, uncertain estimation for prediction values, time series featureization, improve model-based modeling, and unsupervised anomaly detection. These are some amazing features. Amazing features which we can experiment in the neural profit library. And here are the great references for exploring neural profit. So this is the documentation page, and this is the author GitHub repository, and you can check some amazing tutorials also they have. And this is the ARNet library page, and this is the good article between the difference between the profit and neural profit, which has written by Pat. And this is again an amazing thing. And finally, thank you so much. I understand it's always good to take the time seriously, so I respect time. In case if you have any feedback, or questions or any suggestions for me, feel free to reach out to me on my social channels. Feel free to reach out, and I'm happy to address each and everything. And thank you.